I want to be the reason why everybody keeps saying you so happy. He said, I want to be the reason why you're so happy. It's just I keep on saying that's the funny thing I read. Thank you. Yeah, the bitch of right with it. And that's, you know, like, you know, different things, okay? I think that would be by that caption, yes.
You guys remember where the grid is on this thing? What is it? Thought there was a shortcut over here.
That's not good.
Would anyone like to come up here and try this, graphing this? Someone might remember how to do it. All right, please. Do you want it? Sure. And if you could explain it to us, that would be great. Okay.
I have to explain it? Alright. Well, if you plug 0 into x, it's still 0. So, first point is 0.
0, 0.
Alright, so if you plug in 1, it's going to be 1. And then plug in 2. And plug in 3. Hold on. Oh, wait. So that equals 9, right?
Yep.
3 squared, yeah.
So that'd be here.
1, 2, 3, 4, 5, 6, 7, 8. I think one more up.
1, 2, 3.
Oh, yeah. Wait, now I'm confused.
Check the points you've already done. See if they they make the equation true.
Alright, well, I plugged in 1, and 1 times 1 equals 1. So, 1 and 1.
That makes sense. 1 times 1, yeah.
Alright, 2
Equals 4.
equals 1. Oh, yeah, something. Alright, there you go.
So far, looks good. Yeah. So you plotted. You started at 0 and you plotted some points where x is positive. Okay. Why don't you go ahead and see if you can plot some points to the left of the y-axis. See if anything happens.
Alright, so yeah, because okay, if you plug in -1, it'll be positive 1. So
Yeah, you're right.
yeah.
Everyone agrees -1 squared is positive 1.
Yeah.
Alright, so plug in 2, 4, 0, 3.
Now, does this thing go on forever?
Yeah.
Okay. Thank you. Very good.
Congratulations.
Thank you. Okay. So looking at this thing, I heard someone say the name of it. What is this? What is the name of this? It is a parabola. What do you say? And everyone has a joke that they never want to share. Yes?
So you have to do what size do you have?
Well, I mean, there's nothing saying that x can't be negative. So if we just say, is it y equals x squared? The only issues we have in math, it's a good question. The only issues we have in math are division by 0, which is not an issue here. And then we have also, when talking about real numbers, real values, we can't have the square root of a negative number, or any sort of even root, like the 4th root of a negative number, the 6th root of a negative number. So definitely, there's no reason x can't be negative. Yeah. Can anyone tell me? Yes, go ahead. Yeah, you wouldn't. It would be wrong because you're only diminish. It kind of implies that if you did just that, just like the right half of it, so to speak, it implies that there's nothing exists when x is less than 0, and that's not the case here because there are functions where x, cannot be negative. And like I said, like the square root of a negative number. So like y equals the square root of x. In that case, for this real plane here, you wouldn't see it. And we'll get into that when we get to graphing radicals like that. This is a parabola. Okay, is this parabola concave up or concave down? What do you think?
Concave.
It is concave up the whole way. You can see that it makes the shape of the U from all the way from negative infinity to infinity. It makes the shape of a U like this. So that's an easy way to remember that it's concave up. Concave down would look like this. Okay. What type of can you guys tell me what type of equation this is?
Positive.
It's not exponential, but I can see why you might think that because you see an exponent, but it's not exponential. Is it linear?
No.
No. Why is it not linear? It's not a line. Yeah. You can say it that simply. The fact that it's not a line is not linear. You guys ever heard of the word quadratic? Yeah. What's that?
I was just thinking about that. I thought it was going to be one.
Oh, it's okay. It's okay to guess it's something you think it's a certain something. That's okay. It is a quadratic, and the reason it's a quadratic is because the highest degree term is a 2. This period gets out at 12:29, so we got just a half hour left. Okay, I'm gonna do another one, and I want you guys to tell me what you think it's gonna look like. I go to blue here, and I'm gonna overwrite this, so just so the color coding matches, because I'm gonna do a different color. By the way, I don't know if I mentioned to you guys or not, but colored pencils is not a bad idea. I know I didn't list some of the materials on the syllabus, but what colored pencils allow you to do when we start graphing things for homework or a quiz or a test, I'm fine with you guys graphing multiple functions on the same axes as long as it's very clear. For example, if this were blue colored pencil, I could very clearly see, okay, this blue here is this function here because they're the same color. So let's say you have orange colored pencil, and let's say we do this. Y equals x squared plus 4. Would anyone like to graph this? Anyone like to try to come up and graph this? Go ahead and take a shot. Let me ask a question first. If we're not sure what a graph is going to look like before we graph it, what can we do? How can we graph almost anything? Even if we're not sure what general idea what it looks like to begin with, how can we graph almost anything? Almost any function. Practically any function. plugging in points. Exactly what you did. And even if I had no idea what this thing looked like, there's nothing preventing me from just plugging in points. Okay? That might help you in case you feel like you're guessing. Which, go ahead, and if you want to, if you have an idea what you think it might be, go ahead and do that. But then realize you can check. You can always check your points, because every single point on your graph, specifically the ones that you really plot using making dots, they should satisfy that equation. Guys, remember you should take notes if you don't have this. It's not memorized by heart. You definitely want to take notes on this. Okay. How many of you think she's right? How many of you are not sure? They can't see. You guys just sit for a second. So it looks like she just plotted graph just 4 units above the other graph. Every single point you plotted of the 5 points you plotted, they're all just 4 above. Does that make sense the way that looks? In the sense that if you were testing some values, plugging in the x, squaring it, which is what we did with the blue guy, the blue function, but then at the very last step, plus 4, right? Order of operations says add 4 at the very end. So that is correct. Good job. All right. What do we call this? What do we call the orange where it is relative to the blue? Parallel. I could see why you think it's parallel because they will never touch. But that's not the correct term, but I could see why you would think that because you have the right idea. Parallel lines, they never touch. Now parallel is only used for lines. But in terms of, if I wanted that blue graphically to become the orange, how would you describe that? Transition? Okay, that's acceptable. Any other words you guys may have heard? Also starts with an S. If I wanted to have that blue graph become that orange, like where it is translation.
Oh, slide.
Translation. But transition still makes sense. I know what you're talking about. It is transitioning. Translation is the more commonly used to translate. Another word that starts with an S. If you're in a manual car, you have to do this with gears. Shifting. Shifting, translating. These are definitely terms that I want you guys to be comfortable with. You know, to write them down. That shifting and translating are basically synonymous when describing this and graphically. Shifting or translating, depending on what it says in your text or on a test or on a quiz. I want you guys to know they both mean the same thing. So how would you specifically describe what's going on from the blue to the orange? Yes?
It moves up 4.
It moves up 4. Say that again, but with one of the words that we may have already mentioned.
Well, if the blue were what is it, translation to the orange, it would have to move 4 units up.
Okay, very good. That's a very clear, accurate description. It looks like more than 4 units up.
That first dot, the second dot is one. No, I don't know. It's two. Or maybe I'm wrong.
Do you see the dots that are directly above the other dots? If you count each of those dots on the orange, each one, they are exactly 4 units
That's
above.
what I'm talking about. I know that's what I'm talking about.
What do you mean when it's going up?
Do that. That's what I was talking about. So you don't understand, if you can't understand what I said, I don't know what to say.
That's okay, that's okay. When I'm talking about translating the graph, I can tell you this. I'm talking about the entire graph is being shifted up. Now when she drew the graph, this graph that she drew, both of them, they contain an infinite number of points. Obviously, you don't have the time to, well, it's impossible to graph an infinite number, but you wouldn't have the time to graph, say, 100 points or 1,000 points. But when you have a parabola like these two parabolas, the fact that she graphed 7 points on one and 5 points on another, 5 is good, 7 is even better, it's going to be even more accurate. So when you guys do these, make sure you do, I would say, at least 5 points. Okay. All right, so this one's pretty straightforward with the vertical translations, vertical shifting. Let's do green. Let's do y equals -4 squared. This is a 4 here. Would anyone like to attempt this one? It's okay if you feel like you may not be 100% correct. If you want to attempt it, definitely encourage it.
I have a question.
Good question, yes.
Yeah, it says. Never mind.
Anyone want to? Oh, so yeah, does anyone not read what I wrote? I don't know if it's hard to read.
Is it an X minus 4?
Yeah, I have y equals, and in parentheses, x minus 4, close the parentheses, squared. Is it the 4 that looks weird?
For me, it was like the top of the parentheses that looked like a negative to the power of negative 2. Or it was just the green.
Okay, the green, we're going to change the green because it's not, I don't think, the easiest thing on the eyes. Let's do this. Let's go with, how about pink? Is that easy to see? Is that a lot easier? Anyone like to attempt it besides someone that's already, anyone else want to try? All right, go ahead, it's all yours. If you don't mind, let's keep pink just so it's color coded. Now, before you get started, I hate to cut you off. If you look at the blue and the orange, you see the blue that were done, I think you did 7 points, and then 5 points were done for the orange. Each one of those points should satisfy those equations. Okay, so just know that if you want to check your work as you're working, each point that you plot should satisfy that equation. Okay, so what point did you just plot? -4 is not a point.
Oh, yeah, 0.
0, -4, okay. And so what you're saying is when x is 0,
Equals -4.
y should equal -4. See
Oh, hold on.
if that is
The
true.
graph's too small.
Yeah. Yeah, okay, so -4. Okay, -4. Yeah, it's too small.
What do you know what you got? When you said Are you, when x is 0,
Positive 16.
when x is 0, y is, does everyone see that? When x is 0, y is positive 16? Okay,
So
that's true. Yeah, I think it may be too small, but that's okay. So let's see, 1, 2, 3, 4, 5, 6, 7, 8. All right, so that we're kind of out of room here. That's fine. Let's try. Sure, that works.
Go to edit.
Unfortunately, you have to go to edit. I thought there was something on there that should have been a shortcut. It should be something very simple. Grid, and then you have to hit visible in the upper left. And there you go.
All right.
Does anyone have a guess of what it's going to look like before he graphs it? Anyone have an idea? No? Is it going to be? Does anyone think it's going to be a? What do you think it's going to be? Still going to be a parabola? Just it doesn't matter if you're right or wrong. I'm just wondering what you just your initial gut reaction, just for curiosity. You think it's going to be a parabola? Okay. What do you want to raise? Oh, that line's fine. Don't worry about it. Don't worry about it. It's good. It's good enough.
Well, okay. Do you want me to rate here, or do you want me to?
What's
Because
that?
I know it's 16, but like I don't really have.
Can I do it by 2?
You don't have 16?
Well, I do, but it's like all of them.
That's fine. You plotted it. You plotted it.
Alright, so 1, negative 3, so 9.
What's your next x value that you're trying?
1.
Okay.
Alright, so
Now you just guessed on that next one because it felt like you just decided, this is probably your 2.
well, yeah.
I mean, is that the feeling you had? You said, oh, okay, there's probably one here. Let's not assume that. Let's not assume that.
Okay.
I mean, you could test it and see if it's true, but I'll give you a hint. Let's not assume that.
Okay.
Let's keep going with the methodology of plugging in points for x and see what y is.
Alright, so 2. Alright.
I'm the one up here. Yeah, I hear you. Okay. Anyone disagree with that? When x is 2, y is 4? Okay. Anyone disagree with that? When x is 4, y is 0? Okay.
So we plug in -1, -1 equals -5.
And negative 5 squared is?
Yeah. So.
Wow, that's gonna be way off the
Yeah.
chart. Okay. So, okay, what do you think you might want to test next then? If that's way off the chart. So far, notice you got boom, Boom, going down, going down, going down. Well, just keep going to the right. Let's see what happens. Yeah, let's see what happens.
Okay. So. Oh. Yeah.
Now you skip. Now that's correct. You skip 3 though. Try 3. What does 3 give you when x is 3?
Wait, what do you mean?
When x is 3, what is y?
4. 3 minus 4, 1.
3 minus 4 is -1. -1 squared is +1. So that point is correct. Now, here's the thing. Let me tell you this. If you do it this way, and it's a quadratic, which it is, this is going to be a parabola because it's still a quadratic. Notice how that these two here have the same distance horizontally from this guy and the same distance vertically from this guy. You know that's the vertex if that happens. Because you can draw an axis of symmetry through that vertex, and you can then fold each piece of the parabola on top of one another. You guys see what I'm saying? How these two, same distance this way and the same distance vertically from this point, then that there is the vertex. So you know you're going to end up like this. But go ahead and plot a few more points. You'll notice that the guy over here is going to be the same distance that this guy is from the vertex, horizontally and vertically. And then you have the rest. Alright, the graph is almost perfect. The only other thing I would do is I would extend each of those and show arrows. Just to show that it goes on forever. Like go through those points. You have to do an arrow. There you go. So this is what your graph should look like if you're going to graph a quadratic. Some clearly defined points that you've come up with. No, that's good. Thank you. That's good to me. So is this a quadratic?
Yes.
It's still a quadratic. If you were to, could anyone go and expand that for me? Does anyone remember how to expand that? How to expand the right-hand side of that equation, the x minus 4 squared? If you wanted to fully expand that, does anyone remember how?
Like you do it like multiply it by x minus 4, right?
Multiply what by x minus 4?
Multiply x minus 4 times x minus 4.
Mm-hmm. You remember how to do that?
Yeah.
Can you do it for us?
Okay.
Thank you. I really appreciate the courage you guys coming up here, standing in front of the class. Do you guys remember what this process is called that you're doing? There's a name they usually give for it. Do you remember what it's called? Tan spelled T-I-N, foiling?
Yeah.
Remember? I'm not too concerned about you guys memorizing that that's called FOIL, but the reason it's called FOIL is because you multiply together the first terms of each binomial, then the O, the outside, then the I, the inside, then the L, the last guys. FOIL. Yeah? I just want you guys to realize that y equals x minus 4 squared is the same exact thing as y equals x squared minus 8x plus 16. Just to get a visual. Now, this is still a quadratic because the highest degree term is a square term. And the lowest degree term is a constant. I want to quickly show you something that, is anyone still copying this? I want to quickly show you something that's definitely not a quadratic, or not a quadratic. If I said y equals 4x squared plus x minus 2 plus 5 over x, this is no longer a quadratic, and it's no longer considered a polynomial function either, because the lowest degree term is not a constant or a zero term. It's a x to the negative 1. Because remember, well, maybe not remember, but I want to show you, you could write this guy just like this. You guys see that? Because what's x to the 0? Anything to the 0 power, even 0 to the 0 power is 1. Which would still make this, it would still be negative 2. I'm writing everything, that every single term has an x containing an exponent. To show you, this is still written properly, but it's not a quadratic, and it's not a polynomial function. This was originally probably a rational function that someone did long division, and then they had 5 as a remainder, and the original divisor was x. But I'm just going to say that because that's what it is, but just know that you cannot have, this is not a polynomial when you have a term lower than a 0. When you start getting to the negative degrees, it's no longer a polynomial. So, just some examples of polynomial functions. And we have, what, 1229, and then that'll be it. So let's look at just some examples of, if I can draw, of polynomials. You guys have heard this word before? Polynomials. Poly meaning many. So just some examples. Y equals, these are examples. Y equals x squared is a polynomial function. Y equals 1/2 x cubed minus 6 is a polynomial function. So here's one example, here's another example, third example. Y equals 4x to the 4th minus x squared plus 1/2. That's another example. Notice all of these, what they have in common is that the exponents are nice whole values, and again, there's nothing containing a negative exponent. So then just another example, if I had, let's say, 3/5 x to the 6th minus x. There doesn't have to be an x to the 5th term. There doesn't have to be an x to the 4th. They don't have to exist. Just as long as the ones that each term has a power that is 0 or greater. You cannot have any negative x for polynomial functions.
How would you solve it?
How would you solve what? Number 4, there's nothing to solve. This just says y equals 3/5 x. I could graph it though. And here's the thing, how can I graph this? And that's a perfect question, because how can I graph it? Make up points. Let x be 0. I got a point. Let x be 1. I got a point. And you'll start to see it develop. So again, I can't stress enough that just the concept of, even if you're not sure how to graph something, you can just make up points. You can plug in values for x, and see what y is. And if you plot enough points, the shape will come.
Maybe that's what I want.
What's that?
Maybe that's what I want. It was what I want.
We gotta start. No, these are just examples, just random examples. Different. This is an example of a polynomial. This is a different example. This is a different example. They're not in any way connected with one another. This, if they were, that'd be a system that I would not want to have to deal with. It'd be a lot of graphing, and there may be no solution, most likely, if I had to graph all four. But no, these are just 4 different examples. Any last-minute questions about what we went over today? Please ask away. Don't, as long as it's math related, it's not a dumb question. What's that? It's not math related, but it's okay. I'm a little tired. Thanks for asking. What's that look like? Am I not allowed to be a little tired? Are you all excited for the week? How many of you going to the game? Someone say I have to go?
I mean, I want to go to the game. I want to watch the game.
I did
But
say,
I want to, no.
almost didn't sound like it for a second. All right.
I'm not because